Assalamualaikum warahmatullahi wabarakatuh and good morning. So today our subtopic will be work done. It's still under the same topic as energy yesterday. It's just a continuation. So as usual, let's start with our lesson objective. So today the lesson objective is to be able to calculate work done. That's it. Okay, so to know how to calculate work done, the steps to success are 1. Able to define and recall the formula of work done, and 2. Able to apply the formula of work done to given examples with the correct units. So to break that down, you need to be able to define and recall the formula, and then to be able to apply the formula. Right, so it's mostly going to be about mathematical calculations today. Okay, so let's look at what is work done. So, you know what work is? We've seen daily examples of work. Okay, so let's look at some things you would call work. So, when you're completing your homework assignment, you would say you're doing work. When you're running, you'd say you're doing work. When you're walking to your classes, you would also say you're doing work. Okay, not that you walk to your classes anymore. When you're writing your essay, that's also doing work. Okay, this is everyday examples of work. But in physics, work is only when you have a constant force applied, and this force causes the object to move. So definition of work in physics and definition of work in English for everyday stuff is not the same. Okay, so in physics, again, you need a constant force applied. So you need force. And this force needs to cause the object to move in the same direction as the force applied. So you need distance moved. Let's look at some examples. So number 1, when you push a heavy shopping trolley for 10 meters, is this any work done in physics? So again, you need force. So when you're pushing something, you have force. And since you're pushing it in that direction and it moves in that direction for 10 meters, you also have distance. So you have force applied, you have distance moved because of the force. So work done is there. Okay, so you only have work done in physics, you have force, and you have distance. Let's look at another example. When you put on a school bag. So when you're putting on a school bag, is there any force involved? Is there any distance moved because of the force? No, there's no distance here. You're just putting it on at the same place. Force, there's not much force either. So here, no work is done. Let's look at another example. When you push against a wall. So when you're pushing something, there's a force. But when you're pushing against a wall, so you're pushing the wall, is the force moving the wall? Is there any distance? Is the wall moving? No, because you're not strong enough to push a wall. So here, no work is done. Okay, because as you can see here, the person is pushing the wall, but there's no movement. There's no distance because of the force of the push. So again, no work is done. Next one, if you're jumping continuously on the same spot. Okay, so when you're jumping up and down, there's a force involved. Gravitational force. Okay, and kinetic force. So this is your mechanical force. Okay, so you have force, but since you're just jumping on the same spot, you're not moving. Okay, you're not moving, so there's no work done. Oops. No work is done. We've looked at some examples of work done. Let's look at the equation for work done. So work done is equal to force times distance moved, and the distance moved needs to be in the direction of the force. Oops, sorry. Okay, so work done is equal to force times distance moved. So work done, the units is in joules. The letter for that is a capital J. Force, the unit is, as usual, Newton. And distance moved is in meters. That's your SI units. So work done is in joules, force is in Newton, distance moved is in meters. To use the equation. So you're helping to push your mother's heavy shopping cart with a force of 50 Newton for 200 meters. What is the amount of work done? So first thing you need to do is just write down the formula. Work done is equal to force times distance moved. So I'll just put force times distance. So you're looking for work done, so that's empty. Force, here force is in Newton, and it tells you here force is 50 Newton. So just put 50 Newton there. Times distance moved, distance is in meters, so the one in meters here is 200. So just put 200 meters. So 50 times 200 is 10,000 joules for work done. And that's it. Okay, so this is just straightforward. You write down the equation first, you put in the values, and then use your calculator to calculate the formula. Okay, so let's look at a different example. A hiker weighing 150 newtons climbed up a hill and reached the top. So the hill is represented in the diagram below. How much work was done by the hiker? So the hiker started from here, then ended up on the hill. So first thing first, you write down the equation. Work done is equal to force times distance. So you still want to calculate work done. Your force, if you look at the question, the one in Newton is this value, 150. Distance moved, we look at the diagram. So you have three different distance here. 1, 2, 3. Which one will you use for this one? So let's look at the question again. So the hiker is weighing 150 newtons. So the first you're looking at is the weight. So weight is equal to mg, if you remember from your previous physics topic. So because weight is equal to mass times the gravity, here the force that is actually making the person move is the gravity. Okay, the mechanical force, gravity to kinetic. So the one that is involved in gravity, where the force of direction is going up and down. So the one that is going up and down is distance number 3, which is 350 meters. So you put that in. So force was 150 newtons and the distance is 350 meters. Just put that into your calculator and you should get 52,500. Again, the unit for work done is joules, and that's your answer. Okay, so the distance you use is the distance where the force is moving. So you pick that distance. So those were some examples of how to use the equation for work done. Let's think back on yesterday's topic, which was energy. So energy again was the ability to do work, and the SI unit for energy is joules. This SI unit was the same as work done. Yes? So this equation of work done can actually also be used for energy. So work done is the force times distance moved. Again, work done was joules. Meter for distance. So work done, it is actually energy. See the word energy, that can be interchangeable for work done if you're trying to use the equation. Okay, as long as the unit is in joules. So we already talked about work done, we already talked about energy. Let's take a quick look at power. So power is the rate of doing work or using energy. Power is the measure of how quickly work is being done and how quickly energy is being transferred. For now, that's all you need to know about power. Okay, so power is involved in work done and also energy. Okay, you use energy and work done inside power. You'll be learning more about power when you're learning the topic electricity sometime next year. I think it's next year. Okay, so just keep that in mind. And that's it for today. Thank you for your attention.